What if the greatest pressure a nation faces isn't visible on the battlefield, but hidden beneath its own ground? Where water, the most basic necessity of life, is quietly vanishing. Imagine turning on a tap and nothing comes out, not because of a temporary outage, but because the source itself is gone. Farms dry up, cities strain, and stability begins to crack, not from external forces, but from within. That's the direction Iran has been heading toward. But here's the twist: the solution may not be futuristic at all. It may already exist beneath its deserts, designed thousands of years ago. And right in the middle of this unfolding reality, this is exactly the kind of question we explore on History FO Questions, where the past suddenly becomes the most relevant thing in the present. Iran's water crisis is the result of a long buildup of decisions that at first seemed logical. As the population grew and demand increased, the country turned to modern engineering. Deep wells drilled into aquifers, massive dams to control rivers, and pumps that could extract water at unprecedented speeds. These systems created an illusion of abundance. Cities expanded, agriculture intensified, and for a time, it looked like technology had solved the problem of scarcity. But beneath the surface, a silent depletion was taking place. Aquifers, which had taken thousands of years to fill, were being emptied in just decades. Unlike surface water, which can be seen shrinking, groundwater decline is invisible until it reaches a tipping point. Iran's water crisis is the result of a long buildup of decisions that at first seemed logical. As the population grew and demand increased, the country turned to modern engineering. Deep wells drilled into aquifers, massive dams to control rivers, and pumps that could extract water at unprecedented speeds. These systems created an illusion of abundance. Cities expanded, agriculture intensified, and for a time, it looked like technology had solved the problem of scarcity. But beneath the surface, a silent depletion was taking place. Aquifers, which had taken thousands of years to fill, were being emptied in just decades. Unlike surface water, which can be seen shrinking, groundwater decline is invisible until it reaches a tipping point. To understand how Iran can move forward, we need to go backward, into the engineering brilliance of ancient Persia. The Qanat system is not just an old method, it is a masterclass in sustainable design. At its core, a Qanat begins with what is called a mother well, dug deep into a mountain aquifer where water naturally accumulates. From this point, a gently sloping tunnel is excavated, sometimes stretching for kilometers, leading toward lower elevation areas where people live and farm. Along this tunnel, vertical shafts are dug at regular intervals. These shafts serve multiple purposes. They provide ventilation during construction, allow workers to remove soil, and later act as access points for maintenance. What's critical here is the slope. It is calculated with precision. Too steep, and the water erodes the tunnel; too shallow, and the water stagnates. When done correctly, gravity does all the work. Water flows continuously, slowly, and sustainably from the aquifer to the surface without any need for pumps or energy input. This alone makes Qanats incredibly valuable in a modern context where energy resources can be strained or expensive. But the real genius of the Qanat lies in how it protects the aquifer. Unlike deep wells that aggressively pull water upward, Qanats only allow water to flow at the natural rate of the aquifer's recharge. This means they cannot over-extract. The system is inherently self-limiting. If water levels drop, the flow decreases automatically, preventing collapse. This is the exact opposite of modern pumping systems, which can continue extracting until the source is completely depleted. Another key advantage is evaporation control. In Iran's climate, surface water can lose massive amounts to heat. Reservoirs, canals, and open storage systems all suffer from this. But Qanats run underground, where temperatures are stable and sunlight never reaches. This dramatically reduces water loss. In practical terms, this means more water reaches its destination, whether that's a farm, a village, or a city, without being wasted along the way. Now imagine scaling this system using modern tools. Satellite imaging can identify underground water reserves. Geological surveys can determine optimal slopes and routes. Reinforced materials can extend the lifespan of tunnels. Instead of replacing Qanats, technology can enhance them, making them more efficient, easier to maintain, and better integrated into existing infrastructure. This hybrid approach could allow Iran to stabilize rural water supply, reduce pressure on overused aquifers, and create a more distributed network of water access points. Beyond Qanats, ancient Persian innovation didn't stop at transportation, it extended into storage and climate control. The Yakshal is a perfect example. These large dome-shaped structures were built using a special insulating material and designed to store ice even in desert heat. Ice was created during winter and stored in underground chambers where thick walls and airflow systems kept temperatures low. This wasn't just about luxury, it was about preserving food and maintaining supply in extreme conditions. Complementing the Yakshal were wind catchers or badgers. These tall towers captured wind and directed it downward into buildings or across water surfaces, creating natural cooling. In some designs, air would pass over underground water channels, cooling further before entering living spaces. This reduced the need for energy-intensive cooling systems, which in modern times consume both electricity and water. These systems may seem simple, but their impact is profound. In a modern context, integrating passive cooling can reduce energy demand across entire cities. Lower energy demand means less strain on infrastructure, especially during peak usage or disruptions. It also reduces the indirect water usage tied to power generation, creating a cascading effect of conservation. Now shift the perspective slightly. In times of stress, whether environmental, economic, or political, the strength of a nation is measured not just by its resources, but by how resilient its systems are. Centralized infrastructure, while efficient, can be fragile. A single failure can affect millions. Decentralized systems, like networks of Qanats, spread that risk. If one section is damaged or fails, others continue to operate. This creates continuity, which is critical for maintaining stability. Another overlooked advantage of Qanats is their integration into the landscape. They are not visible from the surface in the way dams or pipelines are. This makes them less exposed to disruption and more durable over time. Their design is not about dominance over the environment, but harmony with it. That harmony is what allowed them to function for centuries, often with minimal intervention.
Of course, no system is perfect. Qanats require maintenance. They require skilled labor, and they cannot alone meet the demands of modern megacities. But they are not meant to replace modern systems. They are meant to support them. By reducing reliance on overextraction and high-energy processes, they create breathing room for the entire water system. What Iran is facing is not just a shortage of water. It is a mismatch between consumption and sustainability. The ancient systems addressed this by design. They enforced limits naturally. Modern systems removed those limits, and now the consequences are visible. The path forward is not about choosing one over the other, but about rebalancing, using ancient principles to guide modern decisions. This is where the deeper lesson lies. Ancient Persia didn't survive by overpowering its environment. It survived by understanding it. It built systems that lasted not because they were the most powerful, but because they were the most balanced. And in today's world, where technology often pushes boundaries without considering limits, that balance is more important than ever. As Iran navigates its current challenges, the opportunity is not just to fix a crisis, but to redefine its approach to sustainability. By restoring and modernizing Qanats, integrating passive cooling systems, and decentralizing infrastructure, it can build a system that is not only efficient, but resilient. A system that can endure pressure without collapsing. And if there's one thing this entire story proves, it's that the answers we're searching for today may already exist, quietly waiting beneath our feet. Exactly the kind of insight we continue to uncover on History FO Questions.